Hey guys, this is Eric Weingartner with Weingartner Racing. Today's video is going to be one of the questions that gets asked a lot. People ask me this one quite a bit, or gets said a lot too, is here's the basic question. If you smooth up these CNC lines, does it flow better? I hear that a lot. So in this video, what I'm going to do is I've already flowed this head, and I'll show you which head it is in a minute. But I'm going to flow this head as it is, which has already been done. And then I'm going to smooth these up just with 60 grit to get rid of the CNC lines. And we're going to flow it again to see what happens, so you get an idea. Now, this head, in case you're wondering, is an AFR head. It's actually the 227, and it's the race port, which, in case you're wondering about the part number, is located right there, 1068. I'm going to do a whole product review on this video too, so that'll be the first part of the video that you see. So I'm going to talk about what I like about the head, when I don't, and I'm going to show you the flow numbers before, as it is right now, and then after smoothing it up. Now, in case you're wondering, because I can already imagine some people in your head why you're doing this. Well, again, people get asked. Now, the reason why I chose this head is because I'm getting to port this head. So this is how it came. It's brand new out of the box, but I am going to port this head to get more flow out of it anyway. So smoothing up to 60 grit, it's not going to be that big a deal because I've still got to fully port it anyway, so all that'll be done regardless. So anyway, that's part of the reason for it. But in a way, it's good that this head was picked because this is the race port. And if you know anything about the AFR heads, they have a competition port and a race port. The competition port leaves a much rougher finish as far as the CNC lines go. You can actually hear it. It makes, the reason why they do it is because it takes less time to machine the head. So if there's going to be any type of gain, it would be seen this way, and we're going to find out. So there it is. Now, right now it's on the Superflow, but all the numbers will be from the Sanyas. I actually floated on the Superflow just to see what it would do, and also wanted to play with some of the Superflow stuff just to see some different things and go from there. The Superflow read about 4 CFM higher. Not a huge difference from the Sanyas. But anyway, you can get to see it flowed this way. I'm flowing it with the same, this is a radius entry plate from Brzezinski. I've modified it, obviously, because it's been on different heads. Now, you might say, why don't you use a clay entry? Well, I have a ton. I need to show you this. I don't think I bring up this enough. These are all different clay entries for different heads. And if you watch the LS head one, you'll know that I use these for each one. For instance, this is for my Dragon Slayers. My Dragon Slayers, even though they're a 1206, they're a different entry than this AFR one. And I wanted to keep this test as consistent as possible, so I'm using this. On the LS stuff, I use these. So this was always on the same port. Their shapes don't really get changed or altered that much each time I put it on and off. However, I don't have enough clay to do another one of these. And this was really close, so this is what I'm using. Honestly, it'd be better if I made one of these for each head that I did. But as you could tell, from all the inch radius here, see all these? And all these. And there's another one. And there's some more. That each one, I would have stacks and stacks of plates, and it takes me about, I don't know, 5 minutes to do these, and it'll take me, I don't know, probably 20 or 30 minutes if I had to actually make one. And let's face it, time is money, and one thing I don't have enough of is time. So point being is I ran out of modeling clay. It'd be easier if I just use this. So I put modeling clay in the corners because AFR does have more rounded radius. Point I'm trying to make to this is all of them are done with this plate, not with the clay that I usually use. It was just faster, and it's going to stay more consistent, just so you know. All right, I'll do a little quick review on the head, show you the flow numbers, and I'm going to 60 grit it, and you get to see that. Okay, this is the head. So here's your AFR 227 race port. Now, I had never seen one of these heads before. Which you're like, really? You haven't by now? No, I haven't seen the race port. I have seen the competition one, but I've never seen the race port. To me, I thought they would be like the AFR 220. By the way, I'm talking about the small block heads. And what I mean by that is, if you were to get an AFR 220, the race port head, the vane is not going this direction. It's actually going over here. If you got the competition one, it's the same way. The only difference between the AFR 220 race port and the competition one is the step over, which is how smooth they make this. And let me explain that. When they CNC port, it looks like a lollipop. And what it does is it goes around and it makes a revolution. And then it steps forward and makes another revolution that it makes it for its cut. You could tell the computer how much distance to go for each step. The longer the distance, the quicker it takes to port the head. The smaller the distance, the more time it takes to port the head. But the finish itself gets finer. So the reason why the race ports were supposed to be cheaper is because it takes less time on the machine, less machine costs, should be cheaper to do. However, and that's why the AFR 220, the race port and competition, they look really similar. The only difference is the smoothness. So I was thinking the same thing also applied for this AFR 227 race port. I hadn't seen one except for the competition one, and that's what I get for thinking. This is the race port. Its vane is straight, okay? If you were to give it the competition one, it's actually faced over here, just like all the AFR 220s. Why is that important? It has to do with wet flow. I actually prefer this vane better, but if you're talking about airflow, just strictly air, typically having the vane over in this direction actually helps airflow. It doesn't make more power, I don't believe, especially because of the wet flow stuff and the fuel things. There's a lot, and of course it's a lot of application specific too, because like on LS, the port's entering a different way, so their vane facing that direction, it makes better sense compared to a small block where the port's entering a different way. You might be like, what are you talking about? Pretend there's a cylinder here. This air is entering here. If you look at the LSs, they go this way. So the air is actually going to turn kind of anyway. So I might have that backwards. The point is, where they're entering the chambers, it's different than what the small block is. So this vane's typically what you have on a small block. Although, like I said, the competition ones are over like this. The only thing I point that out is because it changes the airflow on the flow bench that you'll see. So anyway, a little bit more information about the head. It's a 210 valve on the intake and a 1/600 on the exhaust valve. The big difference between the 227 and the 220 is this has a different moved valve. They actually took the intake valve and they moved it 60 thousandths over towards the center. And if you watch my other videos about the LS, when you get the valve further away from the cylinder wall itself, typically it flows more, especially at low lifts. They also moved the exhaust valve 40 thousandths over this way. This spacing is slightly different than Brodix. Brodix has not all Brodix, a lot of their Brodix are standard valve spacing. But you can get like the Track 1 245 and it's a 40-60 spacing, which means it's moved the intake valve 40 thousandths over and the exhaust valve 60. So it's similar to the AFR, but not quite the same. In other words, AFR moves them over this way more and less on the exhaust this way. Brodix moves it 40, they move it 60. Brodix moves the exhaust valve 60, they only move it 40. So they're slightly different, I'm trying to get at. Anyway, the bigger valve, the moving of the valve spacing allows for bigger valves too. Really, within this spacing, you can run a 125 by 1/600. So you can't do that on a standard valve spacing. This should flow more, and I'll actually show you the flow numbers comparing this between the AFR 220, the race port, and I'm actually going to compare it also to the Dragon Slayer because they're all about the same CC wise anyway. And we talk about price difference as well. As far as port work though, just glancing at it, it looks really nice. The chamber, there's a little step here, but it's not bad. It's really pretty good. So all the work there looks really nice. It's a 1206 entry, and I've been wanting to talk about this because this may not be what you wanted to hear in the video, but I wanted to give you more information than you probably thought you needed to know. If you do the pinch measurement, so if I measure the width across here, I should back up. Some people don't know what pinch is. In a small block Chevy and a lot of heads, you're restricted by the area between the push rod and this wall here. This is called the pinch. In all fairness, this is probably the smallest area of most heads for a small block Chevy and some other brands as well. So the way you can get more area there, and you need area to build more RPM horsepower, or if you have a larger cubic inch as well. The way you can get more area is you can either make it wider or taller. So 1206 gasket's pretty common for all things and works with most intakes. This actually has a pretty wide opening. It's like 1.2, and it's because they moved the valve spacing over. So if I move the valve over, Now you got to move the push rod with it. So this rocker stud's moved over, so there's more room. It works better. You can tell they're kind of aligned. So because of that, you have more area here. But the difference is the floor. If you were to get a Brodix Dragon Slayer, which I don't, all mine are ported, so I can kind of show you, but this was what we call a ski jump on the AFR. It actually comes straight up. It tilts like this from where the entry is, all the way up to the short side and down. Because of that, it's from this point to this point, the area is getting less. On a Brodix, it actually comes in flat like this, then humps up and over. And I'll try to show you later. But because Brodix does that, and so does Profiler, there's more area here at the pinch. So you could have more area if you drop this down. It does affect the air as it goes over the short side, so there's a lot of different things that come into play. I want to point that out, probably not what you want to hear, but I'll give you more information you need to know. Probably. All right, everything else is great. 8mm valves and this stuff, lighter valve train stuff. This is what the valves look like. They're really nice stuff from AFR. Anyway, what I'm going to do right now is I'm going to, of course, hit it with a carbide. It's not carbide burr. I'm going to hit it with a 60 grit and flow it and see what changes. That's the only thing I'm doing is doing that. And I'll show you the differences in flow. And then if you stick around, I'll show you the difference in flow numbers between like this head and the AFR 220 on my bench, and also the Dragon Slayer 225. So you can kind of get an idea. All right, stick around because more to come. All right, here's what it looks like when it's all 60 gritted up. I just took a cartridge roll, 60 grit. I spent a little bit of time because the finish is a little rough. So what I ended up having to do is actually use 40 grit first to get this out, then 60 grit, because just using straight 60 grit was just taking too long. So there you can get an idea what it looks like. I'll show you this side. See there? So you got the difference, so you can look at. And then I also did this over the short side, which will be back underneath here. What I did is I took a string of about this long of 60 grit paper, which I have for my flap wheel, and I just took it on my hand and just smoothed up the short side so get rid of that ridge a little bit. That's all I did. So pretty much it's 60 grit the whole way, and just to see what would it do. And then of course I reflowed it. Now just for the record, this is flowed on a 4155 bore. All of them are done the same. So I'm gonna show you the results to see what actually happens. All right, here we have the results. So I only did it on the intake side. I know several people ask, why don't you do it on the exhaust? I'll straight up tell you, if you're trying to get information about the exhaust port on a flow bench, you're really wasting your time. So I didn't. Anyway, so it's just intake. In case you're wondering what the stock AFR 227 race port really flows, not what they claim, what they really flows, that would be this. This is the exhaust, no exhaust pipe. So of course, if you add an exhaust pipe, it will flow more. So here you go. So it peaks at 306.6, and then it actually goes backwards at 7. Several people have asked me why I float a 1-inch, because nobody has a 1-inch cam. Well, that's not always true, but it's because it tells you how stable the port is. Look, it drops and then it kind of hangs in. Okay, this tells me that there's issues with the port. As a head porter, it's important. For you guys, it probably doesn't mean a whole lot of sense. All right, so this is stock, completely stock. This is with the 60 grit finish, and I'll explain what this one is in a minute. This is what happened. So it lost a little there. You really can ignore the 1-inch because the air is trying to suck the valve open. So really, even though I collect those numbers really aren't valid, so we'll skip to those. From 2 on, they really are. So you went from a 148.9 to 140. That's no change. That gained 1.9. It lost a little there, maybe. And then about the same there. It lost a little there. It looks bad, doesn't it? It looks like it lost 3. It lost about 3 CFM. Lost 3 CFM. About the same. Lost a little bit. And it gained. Because the numbers were so tight, all I did is, for this one here, is I just redid the whole entire test. I put it back to 1 and reflowed it again. So really what you're looking at to see the differences in the numbers just from flowing it, to see how much changes just from, error with the machine. Because I do have to explain, there is, if the port's unstable, it really is hard to kind of capture the data because it'll take 20 readings, but it can fluctuate during that. Well, if it's fluctuating on the high side or low side, it'll kind of throw off your readings. So point being is, this is trying to see, because the numbers were so really close, because honestly, if you haven't figured it out, there's not much gain there. You didn't really lose, you didn't really gain. You're like, well, the port's so developed and that's why I lost some flow. Not really. What the thing is not that the port's so developed, is if you change slight things because the port's not great, it can't support it and it just doesn't gain as much CFM. But anyway, for this, you're just looking to see how close it is to these, because it's the same test, didn't change anything. So if you look, ignoring 1 again. 2, it's within 1 CFM. That's within 1 CFM, within 1/10, within 4/10. This one's a bit different, because you can kind of tell at 600 it's trying to act weird, the port is anyway, and that's why it's going to drop after. And you could tell it went from a 303 to 305, that's 2 CFM difference. Not a huge change anyway, but it's because the port's not really happy, because look, after that, 301, 300.4, that's not really that much of a difference. That's about 1.8, that's 1/10, and that's 1/10. So for the most part, the bench is within 2 CFM from test to test. Point I'm trying to make is, you really didn't make any change. So if you were to smooth this up, and I'm just dealing strictly with airflow, the ridges do probably have something to do with wet flow and keeping it re-immersed. There's something could be there, but if you're just strictly doing it, buffing it up, if you're wanting to answer what would it do with it as far as airflow, really not much, anything. However, I will say this is probably application dependent too, because if your head has the ridge, and I've talked about this before on the CNC porting, if there's a ridge right over the short side, if you smooth that up, some cases, just smoothing that up, you gain like 5 or 6 CFM. But that isn't always the case. It really depends on how good the CNC work has been done. But at least on this head, not much of a change, so in case you're wondering. Now, since you stuck around this long, I thought I'd give you more information. How does this 227 race port head compare with the AFR 220? Out of the box, same bore, everything else, okay? Well, I've got the results and I want to share them with you, because really difference is the valve spacing is different and the port's slightly larger, all right? It's also got a different vane. So let me get that. Let me just pull out the card so I just can't see the customer's name. That'd be embarrassing for them. There we go. All right. So let me scoot it down. There we go. All right, this is an AFR 220 on my bench. This is an AFR 227. Let's go ahead and ignore 1. It's worse there, worse there, worse there, worse there. Now it goes 306 at 6. That's about the same. And it's actually better in 7. It's better at 8. It's better at 9. And worse at 1. So it's not as good here for sure. Much better here, slightly better here. Exhaust side, which this one was kind of weird. If you compare the exhaust numbers from this to this, the 220 is better. There's no doubt. Now, both those heads cost about the same. I don't think there's much difference really at all between the cost of these 2 heads. Both of these heads are CNC ported. Now, one of the other heads I sell a lot of, and by the way, I sell AFR heads. I'm a dealer for them, dealer for Brodix too. But one of the other heads, it's about the same CC size, is the Brodix Dragon Slayer 225. It is a as-cast head with a CNC chamber, CNC bowl blend, CNC gasket match. I have done several of them. I found the highest flowing one I had out of the box, okay? Because I flowed several of them, and they do vary because, of course, it's as-cast. I found the highest one. This is the highest one I've had. I've had ones that went about considerably less. This is the highest flowing one I've had. And you can compare those numbers, okay? I mentioned this is the highest one because I went ahead and looked through my data and looked at some of the other ones. One of the other ones, the highest one it went was like a 286. So my lowest one, I should say, the peak it flowed was 286. This is the best one I've ever had that came through. So if you compare its numbers though, 145 beats the 220 and beats the 227. 192, worse, worse. So it's not good there. And then at 4, 245 beats the 220, does not beat the 227. By the way, this is a 208 valve compared to 210, 210. 278 at 5 or 279, worse than that one, and worse than that one. At 6, 295, worse. You can tell. So that Brodix is worse and worse. And then pretty much for the rest of the way, it's also worse. The exhaust side, it's worse, except for peak flow compared to this one. Now, sorry, I just want to forget that peak flow because I used to flow with the exhaust pipe on the very last one, so ignore that anyway. Point being is this one's not as good as any of these. It's close, but it's not the same. So, and remember, this is the best flowing one. The worst one I had, like I said, I think it was 286 at 6, and then it's pretty much stayed there. It didn't jump up anymore. So they do vary. Typically, this part's about the same, the 1, 2, 3, 4, and 5, but after, well, sometimes 5 is low too. At 6, not so much. This being the best one. Now, price difference-wise, let's go through that real quick. Okay, so I just looked up the prices. Sorry for the pause. And it's kind of shocking because I thought I didn't know it was going to go this way. The AFRs, and this is from Summits, they were 1974. It doesn't matter whether you got the AFR 227 or the 220. They were 1974. The Brodix Dragon Slayer on the solid roller setup, same as this one, 1988. Yeah, it kind of shocked me too. These were actually more expensive than that one. The ASCAST one with CNC chambers, CNC bowl blend was actually more expensive than these. So yeah, I guess I didn't pay attention enough on that. I knew they had price increases, but I'm only getting the heads bare and then I poured them so it kind of changes, but I didn't, okay. Didn't know that. But anyway, looks like it cost more there. Alrighty, well, I appreciate you guys sticking around. I'm gonna answer some questions real quick. For the guys that stick around to the end, I'm gonna try to give you guys a little bit of nugget of knowledge or something to help you out throughout the ways, or some bonus since you stuck around, because we all know logistics, you probably don't. Someone asked what check springs I use to do flowing my heads. This is the part number. That comes in a package of 8. If you have a hood and you've got those push locks like the Camaro has, this is actually what I put underneath them to keep the hood pushed up, because it keeps wanting to sit down. It's a pain in the rear taking off the hood before I added these, because it was going to just drop and lock, and taking it off was a nightmare. You have to do like a almost 2-3 man job to do it before these. But I also use these for valve springs. Now, next nugget of knowledge or bonus for you. Coming up, and there's probably going to be the next video you'll see on Wednesday. These heads are 706 LS heads, and they've been put in with the larger valve. You'll get to see the flow numbers for them later on. I've also got the flow review on this. This is a Profiler 210. I'll show you that. I've actually got special things planned for this to show you, kind of neat stuff. That's later on. And also, PRI is this week. It's in Indianapolis. It's a trade show. If you happen to go there, I will be there. I am not putting on a seminar. They don't ask me. I'm not famous enough or whatever, or frankly, have enough knowledge. But I will be there. So in case you're there and you see me, you can say hi, and we'll go from there. But anyway, thanks for sticking around. You guys take care.